So we will see about the next chip, that is 8251, that is USAT, that is Universal Synchronous Asynchronous Read and uh, Transmitter Receiver. Okay, so that we will see now. Okay, before that, let us check whether I have shared my screen and everything is perfect. Okay, so let us see about this USAT. That is okay. So mainly, as I told you, this 8255 and 8251 chip, that is mainly helps us for communicating with the between the microprocessor and the input output devices. Okay. So now we are going to see about this USAT in detail. Okay. So normally you should know about how the data will be transferred by means of this processor, that is microprocessor. It will be in a parallel mode. Okay, so but input output devices will be transferring the data with a serial mode. Okay, so that is like sequentially one after another it will be transferred, right? So there should be some translator in which converting the parallel mode to the serial mode and serial mode to parallel mode for communication. Okay, so this 8251 which helps mainly for translating this particular process for the proper communication, or otherwise this communication will not be effective. Okay, so for that reason also this 8251 which is helping us for converting process, and also the key function is serial communication and data transmission effectively, and data reception. Okay, that is receiving the data, and also error reduction during transferring the data. If any bit which causes error, that error also will be detected. Okay, so that is the main key functions of it. And when we go for this particular thing, you can see like different transmitter, receiver end, and then modem, and then read write control logic and data buffer. So these are all the things you should be clear with. Okay, so let us see first D7 to D0. This we will call it as like a data bus, mainly which is used to transfer the data or control words, okay, between the processor and 8251, that is CPU and 8251. Okay, so and it is also bidirectional. Why? It is bidirectional means both sending and receiving will take place done. Okay, with the same. So mainly here we are having read. Okay, and read, as you know. Okay, CPU which reads the data from 8251 chip. Okay, so and also bar is there. So we can say that when it is active, if the value is low, that means zero means it will be the read will be active. Similarly, write WR, which CPU which writes the data or control to 8251. Okay, so here also active when it is low. So that's why WR bar we have given. Okay, and similarly C by D bar. Okay, that is control or data which selects when CPU is sending. Okay, so one will be control word means zero will be data. That's why we are given C bar D C slash D bar. Okay, if anything is one means another thing will be in the other active. Okay, zero. Okay, so that is how we are given. And then chip select, that is CS we have given. As you know, chip select which enables actually the 825Y 8251 complete pin. Okay, so mainly 8251 to be active using this chip select only. Okay, and coming to the next, we have also have a clock CLK, right? So clock which provides actually the timing, okay, for the internal operations, okay, how to done. Okay, and coming to the transmitter side, you can see that is to the right side, which transmits the data. Okay, mainly you will see like how the serial output data line, okay, will be done, and then data which actually goes out to the external device. Okay, so that's why we have this TX ready, that is transmit ready, which indicates buffer is ready for the new data. Okay, so CPU can send the next cycle, right? So that is actually the meaning for TX ready, that is transmit ready. And next is TXE. Okay, what is this TXE? Transmit empty. Okay, which indicates that transmission is complete. That's why we are using this TXC. And similarly, we will go for TXC. Okay, and then we will go for the receiver side. Okay, receiver side you have a RxD, that is receive data. Mainly here, here also we have only the serial input data line only. So data comes in from the external device. Okay. And then here we have RX ready, that is receive ready. So only the communication takes place when it is translated to the serial mode. Okay. So that's why we are using all this. And then RX ready means it is like a receive ready. Okay. Receive ready means data that is received and ready for the CPU. And similarly, RXC. Okay, so that is receive the clock. So clock signals for receiving the data. Okay, and finally we are having this synchronous detect. That's why we are using this SYN det. That means synchronous detect, mainly used in a synchronous mode, indicates a synchronization achieved. Okay, and these are all about the receiving end. Okay, and then coming to the modem part. Okay, so modem, we will go for the modem control. Okay, in which RTS you have, okay, that is a request to send. Okay, so that's why we are using this RTS, that is request to send when it is required the data. So it will give the signal that is request to send. And then I want to send data. So likewise, that is the meaning of it. And then coming to the next, that is CTS, that is clear to send. Okay, that means from the modem to 8251 the data will be sent. Okay, that is you can send the data. Okay, likewise it send the signal. And then coming to the next, that is DTR. Okay, DTR means data terminal ready. That means actually 8251 to modem, the signal will be sent. That is device is ready. Likewise, it gives the message. And coming to the next, that is DSR. That is data set ready. That means modem to 8251, this signal will be sent, in which it says modem is ready. So everything which gives the request and gives the acknowledgement, and then the data will be sent according to it. Okay, so that's why we can say these are all okay. And then about the modem, how the data will be transferred. And here we have seen about all this. Okay, and coming to the next. Okay, so these are all the explanation about it. Okay, and then we will see mainly about the asynchronous and synchronous mode. Till now, we have seen about receiver and transmitter parts, how the bit is configured. And now we are going to see about the asynchronous and synchronous mode. What is the difference between it? That is synchronous and asynchronous. First, asynchronous example is UART or serial port. That is, we will say it as like RS-232. The keyboard communication can be the best example with CPU, okay, or mouse communication. Okay, so here the data which is sent, for example, in keyboard, if you are pressing one key, okay, so one character at a time using start and stop bits without a shared clock. So here there is no sharing of the clock cycle. That is why we will call it as like asynchronous. But coming here, it is a synchronous mode. Here, example, we can say it's like serial peripheral interface. Okay, so here like Ethernet high-speed network and all is the best example for synchronous mode. Here, data is sent as a continuous stream using a common clock signal. Okay, so that's why we can say it is like sharing the clock signal. Okay, common clock signal. So that's why we will call it as like a synchronous mode. This is the difference between the asynchronous and the synchronous mode in 8251 pin. Okay, this is about the pin configuration. You have in the previous, here you have 28 pins. Okay, for the serial communication between the microprocessor and the external pin. All these things we have already, the transmitter and the receiver part, okay, and the modem part, and then the data, okay, and then the remaining thing, okay, we have seen about the ground chip select and so on. Right, this is how the pin configuration for 8251 which will be done. Okay, the explanation also given for the pin configuration as we discussed about the functions already in the previous slides. Okay, so I hope you got about the pin configuration as well. And these are all some of the applications. Okay, not only just for the translation purpose, but also it can use in modems, serial communication ports, data transmission networks, and microcontroller communication. Okay, all these we are using this 8251. Okay, so this particular chip that helps to communicate, okay, between the uh, processor, microprocessor, and the input out devices in an effective way with the synchronous and asynchronous with transmission and receiver here. Okay, I hope you got the information clear. Okay, with this, this particular topic is over. Okay, so I hope if you have any queries, you can just post in the comments so that I can help you. Okay, thank you. All the best.